We're going to evaluate the integral of cosine of x divided by the square root of 4 minus cosine squared of x. Now, one result we're going to need later is the integral of secant of theta, and that's equal to the natural log of absolute value of secant of theta plus tangent of theta. And another result is the trig identity 1 plus tangent squared of theta equals to secant squared of theta. So let's begin. The first step is to rewrite this integral in the following way. The numerator is cosine of x. In the denominator, we'll write 4 as 3 plus 1 minus cosine squared of x. And of course, we know that sine squared of x plus cosine squared of x is 1. Therefore, 1 minus cosine squared of x is equal to sine squared of x. Now here in the radical in the denominator, we have 1 minus cosine squared of x, so we're going to write it as sine squared of x. So the integral now looks like this: cosine of x over the square root of 3 plus sine squared of x dx. Let's make a substitution. Let y be sine of x. That makes dy cosine of x dx. And rewriting this integral in variable y, we have in the numerator cosine x dx, that's dy, and in the denominator we have the square root of 3 plus y squared. This integral is done by trig substitution. The substitution is y equals square root of a constant, which is square root of 3, and because of the plus, times tangent of theta. That makes dy square root of 3 times secant squared of theta d theta, and then solving for 3 plus y squared. In terms of theta, we have 3 plus y squared equals to 3 plus 3 times tangent squared of theta, and that's equal to 3 times 1 plus tangent squared of theta, and that's 3 times secant squared of theta. Let's rewrite this integral now in variable theta. In the numerator we have a dy, which is square root of 3 times secant squared of theta. In the denominator we have square root of 3 plus y squared, and that's now 3 times secant squared of theta d theta. Let's simplify. We have square root of 3 secant squared of theta divided by square root of 3 times secant of theta d theta. So canceling square roots of 3. Secant squared of theta over secant of theta is just secant of theta. That's all we have left is the integral of secant of theta. That's the result that we needed at the beginning. That's natural log of absolute value of secant of theta plus tangent of theta. And let's add a constant and call it C1. Now we're not done yet. We have to make our way back to the original variable x and express the answer in variable x. Recall that y was square root of 3 times tangent of theta. That makes tangent of theta y divided by square root of 3. So let's draw a right triangle. Here is the right triangle. Call this angle theta. Tangent is opposite over the adjacent, and by Pythagorean theorem it makes the hypotenuse square root of 3 plus y squared. So natural log of secant of theta plus tangent of theta in variable y looks like this: natural log of absolute value Secant is hypotenuse divided by the adjacent, so that's square root of 3 plus y squared over square root of 3 plus tangent of theta, which is y over square root of 3 plus constant c1. Let's simplify this by writing this as natural log of absolute value of square root of 3 plus y squared plus y over square root of 3 plus c1. By properties of logarithms, this is equal to the natural log of absolute value of the square root of 3 plus y squared plus y minus the natural log, we don't need absolute value, of square root of 3 plus c1. This is all a constant, so let's call it c. We don't actually need absolute value because square root of 3 plus y squared plus y cannot be negative, so this is natural log of square root of 3 plus y squared plus y plus a constant c. And recall that y was equal to sine of x. So now we can summarize and say that our original integral, that is the integral of cosine of x divided by the square root of 4 minus cosine squared of x, is equal to the natural log of square root of 3 plus sine squared of x plus sine of x plus c.